Find the volume of the solid that results when the region enclosed by the curves is revolved around the x-axis. All right, so what you have here is called the washer method. Just go with me here. Pretend that this little blue sliver is going to be spun around, or better yet, pretend that your finger is on this x-axis and you're slowly spinning this around. And when you spin this around, it creates like a kind of like a cone-shaped solid, almost like a bowl without a bottom. All right. Now what you have is a 3D figure created by this thing being spun around. That's what we're dealing with. Okay, this method is called washers. Now, there's another method called discs. It's on my YouTube. Look it up. But the washers method is called the washers method is when you spin it around the x-axis, there's this gap in between the actual curve and the x-axis. If there's no gap, if it's something that's attached to the x-axis, that's when you would use the disc. But this is called the washers because like a washer as a tool, you have that hole in the middle. So we'll have that. The way you do this is you set up an integral, right? You throw pi in front of it. You have an upper limit and you have a lower limit. And a lot of teachers use r to represent one of these. So you're going to have like both of your equations. I'm not going to figure out which equation is which. I'll explain that in a minute. But you're going to have like an upper equation, the equation that belongs on top, okay, of this solid. You're going to call that r sub o. And you're going to square it, and you're going to subtract r sub I, and you're going to square that, close that, dx. Now, again, when you are creating your integral, the r sub o is going to be the top part of the solid or the top part of the area. So this equation right here is going to be my r sub o, and this curve is going to be my r sub I. All right, so let's label what I know now, okay? And there's a few things that we have to do before we can even get started. First thing is I now know that this is going to be, this curve is my r sub I. So the parabola, which is this equation, is my r sub I. This is going to be my r sub o, so let's put that in our back pocket. What we also need is my upper limit and lower limit. Now, it might be obvious here, but what if it wasn't obvious? I have to find what x value this is, which is now called a, and I have to find out what this is b. Now, it looks like 2 and 0, and it probably is 2 and 0, but what if the numbers aren't as friendly? What if the equations aren't as friendly? What do I do then? Well, in order to find the x values that these guys intercept, I have to solve the system of equations. So just like you would do like, a regular system of equations, I'm going to use substitution. It's y equals this and y equals that. So set 2x plus 2 equal to x squared plus 2. Now I'm going to set this equal to 0 by subtracting 2x. Nothing combines over here. If I subtract 2, that makes my life a little bit easier because that all cancels out. And now I'm left with 0 equals x squared minus 2x. Okay, using the zero product property and a little bit of factoring, I get x times x minus 2. Set both of these equal to 0. And one of my limits, this guy is 0, so I guess I was right. And if I were to say x minus 2 equals 0 and add 2 to both sides, 2 would be my other limit. So now what I know is I know that my upper limit is going to be 2. My lower limit is going to be 0. My r sub 0 and r sub I is already set. Now we can get started. So let me erase this whole mess. I'm not going to clear the screen because I want to keep this stuff over here. Okay. All right. I'll probably have to write small because I have a feeling this is going to be a mess. So I've got 2 and 0. I've got r sub o, which I said is going to be my line. So I have 2x plus 2 squared minus x squared plus 2 squared, close it, dx. Okay, before I even think about integrating, I need to do a little bit of simplifying in here, so let me do just that. Okay, perfect square trinomial. So this part becomes 4x squared plus 8x plus 4 minus another perfect square trinomial. There's my phone. X to the 4th plus 4x squared plus 4 blip, blip, dx. Let's combine like terms. Still not even close to being done yet. Not even close. I've got, what's it called? Distributing the negative. So I have 4. I can drop these parentheses. 4x squared plus 8x plus 4 minus x to the 4th minus 4x squared, which is good news. And you'll see why. And more good news. So I take it all back. This wasn't so bad at all. Minus 4, close it, dx. So you'll cancel out. You'll cancel out. And I'm left with 8x and negative 4x. So I have the integral between 0 and 2 of 8x minus x to the 4th dx. Once I integrate, that pi is just going to live right out there. All right. So I have the integral of 8x is going to be 4x squared. The integral of minus x to the 4th is going to be negative 1/5 x to the 5th. And my limits of integration are 0 and 2. All right, so let's leave this pi out here. Let's leave this pi out here. That pi is just going to exist out there, and I'm going to make sure that I keep it attached to my final answer. I hope I gave myself enough room. Fundamental theorem of calculus time, plug it in. So let's try to do as much in my head as I can. I have that pi there. I'm going to plug in 2. So I'm going to have 4 times 2 squared, which is 4 times 4 is 16, minus 1/5 times 2 to the 5th power, which is 32. So 32 over 5. I'll deal with that when I have to deal with that. Minus pi. 0. Oh, look at that. Look at that. If I plug in 0, I get 0 minus 0, which becomes 0, which makes all that 0. So I'll just completely erase you to make my life a little bit easier. 16 minus 32 over 5. Ugh. I'll consult Siri. 16 minus 32 fifths.
The answer is 9.6.
So this final guy is going to be, what the heck? This final guy is going to be 9.6 pi. So yeah, that's the washer method. Very similar to the disk method. Again, this is the washer method because when you spin it around, you get that space in between, unlike the disk. I have a video on that. Go find it. It'll be great for you.